Okay, let's talk a little bit about biasing. And what is biasing? Well, when we take a signal, any AC signal, we look at it, we see that it is usually hovering right around this 0 volts mark. Okay? A normal AC wave, whatever its amplitude, it's going to go up. In this case, I've got 1 volt up, 1 volt down, and it will repeat whatever its time constants, whatever its period is, it's going to repeat over and over again. But it's always going to do this right around 0 volts. Okay? This is a 1 volt peak, 2 volts peak to peak sine wave. Okay? If I add a DC source to this wave, I can move it up so that it will center itself or hover itself right around 1 volt. So this is still a 1 volt peak, 2 volts peak to peak wave. It's still a sine wave, but I've put an AC source in series with a battery of 1 volt. And that is injecting that DC voltage in, and it's moving it up. Also in this case, I've changed it from an AC to a DC wave. It's DC now because it never crosses the 0 line. So that is a DC sine wave. Okay, down below, I've created another 1 volt peak, 2 volts peak to peak wave. This one centers around minus 1 volt. And that one is an AC source with an upside down battery of negative 1 volt. What makes it negative? Well, it's upside down, and the ground reference is in a different place than it would be if the battery was, quote, right side up. It's just the direction of the current. So that one is suppressed by 1 volt. It's also DC because it's never crossing the 0 line. It happens to be 1 volt lower. So that's a little bit about biasing, and that is going to help you figure out what to do with your waves for worksheet 6 and 7 when we get into biased diodes, biased clippers and clamps.